Greetings. Today I want to implement multiple subpartitions in a single volume that spans multiple disks, or at least multiple disk partitions. Yeah, that was a mouthful. I'll be using a B-tree file system, probably better known as btrfs, btrfs, or btrfs. Any one of those, that's what I'll be using today, and I'll be doing it with Debian Trixie, which was just released a week or two ago, so this is going to be a first here. btrfs or btrfs considered an advanced file system because of features like volume management, snapshots, error correction, and things like that. And I'm going to be giving it a try instead of using something like ext4. I have been using btrfs on my Fedora install, which is part of another test run, but so far going pretty good, but I figured it was time to learn something about it. Okay, so Debian 13 Trixie, like I say, released a couple weeks ago, does provide btrfs support. It provides full btrfs support. However, the installer has a limited set of btrfs or btrfs support. Basically, with the installer, you can install a volume on a partition and a single subvolume within that partition. However, you can do that on multiple partitions. So some might not really consider that a limitation. However, I wanted to try and get it set up closer to what Fedora does. So I want one volume, again, spanning multiple drives with two subvolumes. Well, you could have more or less, but I'm going to have a root subvolume and a home subvolume. Depending on the type of computer I'm building, there could be more or less, but for this test, it's going to be two. One common practice I have noticed is a lot of people use btrfs, create a snapshot volume to hold snapshots, which is one of the advanced features. We're not going to be looking into that. Maybe at a later date, I'll look into snapshots and create a snapshot subvolume. We'll see. So the big question is why somebody might want to do this. Well, there's a couple of reasons. The big one being subvolumes are dynamic and that they can grow and shrink as the need arises. This makes better utilization of existing disk space, so that's one of the reasons I'm using it. On my current laptop is I don't have to break it apart into a bunch of partitions. The subvolumes will grow and shrink as the need arises. So for this particular test, I'm going to be creating a virtual machine with three virtual drives. I'm going to install Debian Trixie, Debian 13 on one of the drives, and I'm going to make the main root partition, which again, basically, according to the Debian installer, a btrfs partition. And then post-install, I'm going to modify it to include a home partition. And then I'm going to expand it across several drives. And I did this experiment at least 6 times before I finally got it right, but there were some things I learned we'll talk about. I also want to note that there's a mid-install method where you use the advanced installer in Debian and you break out of it after you format the hard drives, but before you install the system. And it's actually kind of similar to the post-install, except you're dealing with the Debian installation environment instead of the straight-up Debian environment, which, again, I'm more familiar with the Debian one, so maybe it just seems simpler to me to do it that way. So basically, if getting the last iota of data storage is what you're after, yeah, I'd say the subvolumes are the way to go within the volume spanning all your drives. So no need for you to figure out how big each drive should be, and hopefully you're not wrong. Like I say, the subvolumes will adjust. I will say that it's been, well, I've been using this with Fedora for a while, but I haven't actually done a lot of research into btrfs, so this is going to be a learning experience for me too. Like I say, it was automatic on Fedora to do it the way I wanted to do it on Debian, which it's not. So yeah, this is going to be a learning experience. We'll see how it goes. We might have a few issues along the way, but you know, so be it. All right, before we get started here, there's a few things we need to discuss about the btrfs file system. I think I'm going to call it btrfs. I like the sound of that. Anyways, btrfs is a file system that combines Volume Manager with a copy-on-write file system. It offers several advantages of features not found in traditional file systems like ext4, for example. So one of the basic features advertised is copy-on-write, or COW, C-O-W. Basically, instead of writing a file change right away, a marker is placed and, well, it's placed and used on the drive, and the file is only written when changes are saved. And only the change blocks are written. So in theory, this can extend the life of the solid-state device and limit data loss when things go south. I haven't had an issue with it yet, so yeah. Snapshots is another feature that we have in btrfs. Takes a picture of a subvolume at a particular point in time. They are used as a means of rolling back changes to that subvolume to a previous state. They are not backups, but they are basically, like, say, snapshots of a condition before you load a new set of packages or something like that. And speaking of volumes, we have volumes and subvolumes. These are the basic structure of the file system. A partition or a disk can become a volume, and then you can place subvolumes within the volumes. Interestingly, subvolumes within a volume can grow and shrink depending on how they're being used and space they need, so it's a much more efficient use of hard drive space. There's also several types of compression available in btrfs. This, again, reduces size of data written and can improve the life of SSDs and increase overall file storage efficiency, at least as far as space goes. Obviously, for compression, there is some overhead. Data checksums is another feature found in the btrfs file system. Before you write data to the drive, a checksum is generated, and then after the data is written, a checksum is calculated for what is on the drive, and then the two are compared, and if they're the same, hey, no error occurred. Okay, pretty simple, straightforward. It has its own system scan tools, system maintenance tools. They can check the file system for issues and repair them. While not recommended, though, you can force these to run on a mounted file system also. And btrfs supports various levels of RAID, redundant array of inexpensive disks. Comment a little later on that, though, as to how well they support it. And of course, with these advantages, there come some real disadvantages. You should be aware of those. Complexity, it's an advanced file system. It's far more complex than something like ext4. It has a higher learning curve. It's much more involved than simply formatting a partition like you would at the ext4. There's also some maintenance that needs to be involved in upkeep over time. And stability, again, time-wise, btrfs or btrfs is one of the new kids on the block. It doesn't have a history like ext4. It's often compared to ZFS, which is an older file system also, but similar in many ways. But yeah, it's a newer file system. There are some stability issues. I've been using it for about 6 months now, and I haven't had too many problems, but also want to state that there's continued work on btrfs, so what's a problem today may not be a problem tomorrow, so it's constantly evolving. And we can't go forward without mentioning overhead. Yes, more complex file system, more overhead. This is going to be particularly evident on low-end hardware or systems with limited resources. I have not really noticed anything too terribly different using it on my laptop, but then I got an i9 processor and plenty of memory. But I have noticed some differences on virtual machines with limited memory and limited processor cores. So you need to take that into consideration too. There are a couple other considerations I really want to mention. Unlike some other advanced file systems, ZFS, for example, or LVM even for that matter, I mean, it's not as advanced, but it has several features. But btrfs does not have its own built-in encryption protocol, at least not as of the time of this recording. This is not an issue for most people, as there are third-party alternatives available to support encryption, but again, depending on how important your data is and what your workflow is like, what your tasks are, this may or may not be an issue for you. And another consideration is RAID stability, specifically RAID 5 and RAID 6. Those are RAIDs with anyway, striped disk seems to have a problem with it. It does fine with RAID 1, like RAID 1 or RAID 10. Parity data, that's what it's called. A striped disk with parity data. That seems to cause it some fits sometimes. Again, one of those things being worked on, it's just not there yet. All right, let's go ahead and create our VM. We're using the virtual machine manager. We'll go ahead and fire that up and start a new VM. We're going to rush through this kind of quickly as I cover this in other videos. If somebody wants an actual dedicated video to this process, please let me know. So we select our Debian 13 and we just, like I say, run through the process. One thing I'm going to do here is I'm going to create multiple drives. So I have several to attach to this machine. So when we get ready, make sure you click this customize configuration before install, before you exit the new VM wizard window. And like I say, we're going to add some additional drives. We're going to go to UEFI boot, etc., etc. And like I say, I'm going to create 2 different size disks, which I'm going to add to the VM. So like I say, rushing through this, but if anybody wants a more detailed video, let me know. All right, the next thing we want to go through here is the base install. Once we've got our machine set up the way we want it, again, we're going to go through a lot of this fairly quickly. We're going to stop at points of interest. Yes, I am creating a root account. It's up to you whether you want to do that or not. Okay, when we get to partitioning the disk, we're going to use guided use entire disk. And again, I've got 3 disks attached, so it's going to be virtual disk A. Yours could be SDA or NVMe. It just depends on your system. And we're going to use the all files in one partition. And then once the disk partitions, you're going to see we have a ESP, which is our EFI partition. We have a swap partition, and the rest of it's taken up with our root partition. But this is ext4, so we want to go up to select this and configure it, and we're going to change it to btrfs journaling file system. Then we're going to go to mount options, and I'm using no a time and compress. And now that we've got it set up as a btrfs, 1 partition, 1 volume, and 1 sub-volume, we're going to go ahead and save that off and finish the install. When I get to the task select, I'm deselecting everything and just, well, I may install SSH server. So then I'll add some additional hardware later, specifically sudo, since that didn't get installed. But anyway, this should finish up and we should reboot into a login screen. Okay, before getting started, we need to jump into exactly what we're going to be doing. So we've got our post install subvolume is at root fs. That's what Debian calls it. We didn't change the name, and it's located at the root of our file system. So all well and good here. So what we want to do in this test experiment, if you will, is we're going to map the dev vd2, which, if you remember, that is our volume, to /mnt on our main file system. And yes, the root fs subpartition is in vd2, which is the same as the root fs that's the base of our system. This may seem a little confusing, but we can do it. I wouldn't recommend operating this way. We're just doing one specific thing here. Then we're going to unmount the partition. And that specific thing is we're going to create a at-home subvolume on vd2, which is our volume. So now we should have 2 subvolumes there. Then we're going to unmount it. Next, we're going to mount our subvolume, the at home, to MNT. And then we want to copy over our home/user folder to MNT, which is, we'll drop it in the subvolume at home. Then once we do that, we can unmount it. And then finally, we're going to mount at home subvolume to the home folder in our main partition. And it should be empty because we moved it all to a home folder. And once we check We can go ahead and look in the home folder and we can see that our user directory is there. So this is how we want the system to look, at least on the single partition volume that we set up so far. So we need to make these changes permanent by writing them to FSTAB. Okay, the other thing we want to do here is we want to combine our 3 drives. Now, there are a couple different ways to do this. We've got drive A, VDA, which has 3 partitions on it right now. These include our EFI partition, our swap partition, and then in our VDA2, we have our root and we have our home partitions, subvolume. We have our root and our home subvolumes there. So what we want to do is add on to VDA2, and I mean, you got to keep this clear. The volume VDA2, we want to add VDB and VDC, but we don't want to add the drives. What we're going to do is we're going to partition each of these drives, so we'll have a VDB1 and a VDC1, and then we're going to add those to the VDA2. I had interesting experience trying to add the drives directly to the root, and it didn't work. And there were some issues on one of the tests with actually trying to use the whole drive and it wiping out what was on those drives. But believe me, we want to create partitions on drive VDB and VDC, and then we'll combine those with, we'll combine VDA2 with VDB1 and VDC1 to make our large drive. It sounds a little complicated. I'm probably not explaining it well, but yeah. Okay, let's go ahead and log in. I'm going to SSH in using PuTTY. You could also do SSH in through a terminal. So the first thing I want to do is find all my mount points. So I'm going to use find mnt real, /real, and that's going to show us our 2 mount points that we have so far, our VDA1, which is our EFI partition, but you'll notice that our root partition is dev VDA2 and then at root FS, which is a subvolume. Some of the stuff scrolls off the screen, so we can actually write it to a temporary file and then look at the with a cat command. We can look at that temporary file and see the stuff that scrolled off the screen. Okay, let's just go ahead and remove that temporary file. If we look at ls block, we can see we got our VDB and VDC. We look at EF or disk file system with a -H for human readable. We can see our root volume is 19 gigabytes, 17 gigabytes free, 5% in use. Okay, let's do this now that we've checked everything out. So as I said, the first thing we want to do is we want to create our home subvolume. So for that, we need to mount the volume to MNT. Note when we use the mount, we use the -O for option, and subvolume ID equals 5 is always the volume. So we'll mount the volume and sudo, got to sudo it because I'm not root. Anyway, if we do an ls of mount now, you can see our at root fs. And again, as I said, this is the same as our root file system, but because we're mounting the volume and not the subvolume, we can get away with this. Okay, we can do a df-h, still the same, but if we do a find mount /real, we can see now that we have VDA2 mounted. But there's no subvolume, so it's the volume. So what we want to do is we'll use btrfs subvolume command create, and in it mount will create at home, and we need sudo. And if we do an ls, we can see that we've got both a at home and at home or at root fs folder now here. So let's go ahead and unmount. Okay, for our next act, we want to get the home folder, the at-home subvolume mounted to our mount point /mnt. So we use this sudo mount -o and then subvolume equals at home, We'll use the compress and no a time, which we use when we set up the original volumes, and dev VDA2. So we said we're going to mount the sub-volume home on dev VDA2 and then to MNT or the mount directory. And if we ls mount, it's empty. It should be because there's nothing in there. We just created the sub-volume home. So let's go ahead and use sudo and move or home/rt or home/user data, mine's RT, to the mount folder. And now we can see it's there. We can go ahead and unmount it. Now our next step is to mount said home folder or to our actual home directory. Since that should now be empty, we copied our user directory over. So sudo mount tech O for options, sub-volume, home, or options. We use the same ones again, and dev VDA2 to home. And once that's done, now our actual home folder is where it's supposed to be. So if we do an ls of home, we should see our user folder, and that's where we want things. Now the trick comes in setting up our FSTAB file to do this automatically when we boot. So what we want to do, we're going to edit our etc FSTAB and we want to mount our sub-volume home to the home folder. So we're basically going to copy the initial mount point we're using and just change a few things. So I'm in VI, you can use Nano or whatever text editor you want. Just remember you need what permissions to edit the etc/FSTAB files. VI, I'm going to double Y. I'm going to hit the escape key a couple times. I'm going to hit the escape keys to make sure I'm in command mode. Double Y to copy the file, and then P to paste. Double Y to copy the line, and then P to paste the line. Then I'm going to go in and edit it. So instead of root, we're going to go to home folder here. And instead of sub-volume root FS, we're going to go sub-volume home. Okay. Then we're going to save our changes. Since this is VI, it's escape : WQ. Okay, that's done. And then we just got to reboot. So after reboot, we can go ahead and log back in. And if we do an ls of home, we can see our user folder is where it's supposed to be. We can do a btrfs sub-volume list. And we can see we've got two sub-volumes. They're both have a level 5 parent, which is our volume, but one's 256 is root FS and 257 is home. And if we look at ls block, we can see VDA2 now has got /home and just a slash, so it's got the two partitions there. And DF doesn't show us anything new anyway, so that's it. It's done. Next thing we got to do is expand the volume and mount the additional drives. All right, let's do an ls block. So we got VDB and VDC as our block level drives. I am going to be using fdisk. You can use cfdisk, parted, whatever you want. I'm going to be using fdisk. And we're going to do a G for making it GPT, and an N for a partition. We're going to go through defaults, and then W to write. And we're going to do that on both VDB and VDC. And if we do an ls block afterwards, we're going to see that we have a VDB1 and a VDBC1. So now we're going to mount, again, TACO volume ID 5. Remember, that's our volume and not any of the sub-volumes. And we're mounting it to MNT. stop being fat-fingered. Then we're going to use btrfs device add, and we're going to add dev/vdb1 to mount. Again, got to stop being fat-fingered here. There we go. And then we're going to do the same with VDC1. And if we go to sudo btrfs file system, oh, we got to unmount it first. Okay. We'll go ahead and reboot. Okay, once we've rebooted and logged back in, we'll do our find mount --real. Again, fat fingers today for some reason. ls block, everything looks good. Now if we do a df-h, we can see that our root partition is now 59 gigabytes, meaning we added the 10 gigabyte and a 30 gigabyte partition to it. So everything's copacetic there. Cool, we're done, I think. Okay, there we have it. It only took 6 tries to get it absolutely right. I'm hoping my issues will help you if you want to go down this path. Yeah, I do consider btrfs stable enough for desktop use. I would say a majority of the issues I ran across while I was doing this test came from my unfamiliarity with the file system, but like I say, a little study, a little research helped me get over that. Volumes are either partitions or entire disks, and subvolumes are part of partition, or well, subvolumes are part of volumes, which are partitions or entire disks. But subvolumes are their own logical entity, which is something I didn't realize up front. We proved this, or I proved this during my test when I actually mounted my root file system. Then I mounted separately the volume which contained it. So yeah, that showed me they were basically separate, even though they were logically contained within one another. Another point where this became apparent to me was when I tried to expand across multiple disks. If I tried to expand the root volume or the root subvolume, it caused problems and I couldn't reboot. I had to actually mount the volume that contained it and expand that. But yeah, as I said already, btrfs should probably make a good desktop file system. I do have some questions concerning servers. Let me give you an example. I ran a web server a while back that came under attack, and the attack basically filled the variable and temp directories. Since they were sitting in their own partitions, once they were filled, the server went down, but it was easy enough since the root partition was still had space available. I logged in there and was able to clean up the other 2 partitions to get the service up pretty quickly. If this had been sub-volumes, they would have continued filling until everything was filled, and then I might not have been able to log in as root. I mean, if you're using btrfs in this sort of situation, you probably want to use fixed size volumes on separate partitions. I mean, you could do that, but yeah, I do have a few questions concerning using btrfs on server. I am totally good with using it on the desktop though. So yeah, big thumbs up. btrfs, better file system, btree file system. I will be using it on my, when I deinstall Fedora. After my test is over in a couple months, and whatever else I install, I'll probably be putting the btrf file system on my laptop for everyday use. All right, one final thing before I close here. I want to thank everybody for watching, and I want to ask that if you're watching this all the way to the end, that you subscribe to the channel, that you like the video, and that you leave some comments. I like reading comments and exchanging with people. I'm doing this because I enjoy doing it, but I do want to offer special thanks to quite a number of people who've offered me support in both monetary and hardware. It really makes me feel good. You know, they didn't have to, but they did. I would have continued doing this either way. But I do appreciate the recognition and the support that implies. As I said, I do this all by myself, so yeah, this is not as smooth and professional as a lot of the other YouTube channels you're going to find, but I do it because I enjoy doing it. I enjoy you know, when I was working, I did a lot of teaching stuff and I enjoyed that. So that's why I'm doing this in retirement. Also, one additional thing before signing off, I've got some personal issues going on here, as well as the move to the Philippines coming up in a couple months. So I try to do videos every week or two, but things might be a little sparse. September, October, November, till mid-November, maybe late November. We'll see how things go. Like I say, I've got some stuff going on personally, and I'm getting ready for the move to the Philippines. Again, thank you to everybody for watching, and share this video, like, comment, subscribe, and we'll catch you all next time.